Okay, we're leaving proofs behind now, and we are going to some calculations with inequalities, which is a good source of exam questions. First lecture is just going to be about solving linear equations in one variable. So it's a very straightforward exercise, just doing a little bit of algebra. So let's get on with that. So linear inequalities in one variable. Right. So they all look the same. We consider everything's going to be a real number here. So inequalities of the form ax plus b less than or equal to cx plus d, with a, b, c, d all real. These are going to be constants, and x is going to be the one variable. So x is variable, but it's also going to be taking values in the reals. Okay, so we know that we can, without disturbing the inequality, move anything from one side of the equation to the other by adding or subtracting. So let's move the cx over to the left, let's move the b over to the right. So this is true if and only if ax minus cx is less than or equal to, and I'll just put d minus b. That's true if and only if x into a minus c is less than or equal to d minus b. And I would like to divide by the a minus c, but I have three cases to consider. If a minus c is bigger than 0, then I know I can divide through by a minus c without disturbing the inequality. So if a minus c is bigger than 0, then this is true if and only if x is less than or equal to d minus b over a minus c. And that's going to be my solution. So in this case, I'm getting all of the values of x less than or equal to this. So, so the solution set is just going to be, well, I get everything from minus infinity all the way up to whatever this value is, d minus b over a minus c, and I'm going to include the endpoint. All right, so that's one case. Another case is if a minus c is less than 0. In which case, I know I can divide through by this number, which is negative, as long as I swap the sign over. So x now has to be bigger than or equal to d minus b over a minus c. And then, so the solution set, in this case, is everything up to plus infinity from whatever this value is. So d minus b over a minus c, and we include the endpoint, and we go all the way up to infinity. And then what have we got left? Well, we've got the possibility that a equals c, and that's i.e. a minus c is equal to 0. And if that's true, then all of this vanishes. So I've just got two cases to consider further. Then we have 0 is less than or equal to d minus b. Now, this is either true or it isn't. So there's two more cases. So if this is true, then it doesn't matter what x was. It will always work. Then solution set is just x in the real numbers. Or I could write x in minus infinity to plus infinity. And if it is not true, then it's never going to be true no matter what x is. Then the solution set is empty. And we could write that in various ways if we wanted to, but that will do as a perfectly reasonable way of saying it. So those are the four things. I'm just now going to give 4 examples just to illustrate them. And of course it didn't matter that I was using this particular type of inequality, the less than or equal to, and what it became. I could just use less than, or I could use greater than or equal to. So let's just do some more examples like that. So let's take x plus 1 less than x minus 1. So this is a case where a and c are the same. So this is true if and only if 1 is less than minus 1. Is 1 less than minus 1? No, it is not. So x is in the empty set. There are no solutions. If I swap these around, if I had x plus 1 bigger than x minus 1, then that's true if and only if 1 is bigger than minus 1, and that's always true. And so x is in any real number will work. And then let's just take one more case. If we have 2x plus 1 bigger than 3x minus 3. Let's look at that. So take 3 over to this side, take 2x over to that side. This is true if and only if 4 is bigger than x. So in this case, the solution set is x is in. So anything that is less than 4. So it's anything from minus infinity all the way up to 4. And that's how you do linear inequalities in one variable. And we'll look at quadratic ones next.